Joe Olson here with Phenomblue. I have an exclusive interview with the Genesis team, which was the team that was in charge of building the Genesis project for our South by Southwest partnership with Microsoft. You can see that project on phenomblue.tv. I got Jason Bijot here, who is in charge of porting a physics library over to WPF for the application. I've also got Jason McAvoy here, who is a developer on the .NET side on the team, who's in charge of building the menus and kind of the overall application. And then I'm here with Jim Wagner as well, who's in charge of the graphics side. And so a lot of the intros, outros that you see in 3D, as well as a lot of the objects in the application itself. So I guess I'll start with Jason here, and you want to just talk to us real quick about kind of the experience and what it was like porting the Flex physics engine over to WPF, and kind of, this was your first Surface experience, right? So how was that, and kind of talk to us about that process.
Oh yeah, this is my first Surface app, and really my first foray into the entire .NET side. Coming over from Flex and ActionScript was actually pretty easy. After about the first couple days of being frustrated at the language, just not knowing it, and just kind of finding my way around with it. I really got used to it pretty quickly. I didn't even do any testing up until maybe a couple days after I'd ported everything over, and my first test just worked without any problems. Cool.
Now, Jason, you had a lot to do with the menu system and kind of the underlying works or guts of the system, the Genesis application. Tell me what that was like, and kind of some of the experiences you had on the project.
Well, for me, it was my first Surface app too, and really my big dive deep into WPF as well. Cool. So with the menu system, it's just real basic animations that get fired off based on contacts. With other objects such as planets, sun, stars, and everything like that, just used Jason's physics engine, and then just based on where his points are, I move my objects in response to that. I ended up having to do a lot of 3D modeling, incorporating Jim's 3D modeling into that, and having to run each object in its own thread.
Cool. So this was a multi-threaded application too,
yes.
Which is really neat. Okay.
Yeah.
And then when you were building the menu itself, it was kind of a cool menu, and how it was kind of a new interface where Surface is kind of new, so kind of every interface you build a new interface for it, right? Can you talk about how that was to program? I know there were some difficulties around not being able to sense whether two fingers were close to each other and that sort of thing.
Sure. Yeah. What we did was we built a contact helper class that basically kept track of all our contacts on the Surface. So if one contact was pressed down and the menu started up, as long as that contact was down, within a certain distance, you couldn't place another contact and start another menu. In that sense, you couldn't have menus colliding and things like that. And with that, with the sliding of the fingers, just real basic, just checking to see where that contact is, and when it moves, if it's over a certain part of that menu, then fire off the next part of the menu. And
Cool. And Jim, you had a lot to do on the graphics side, so talk to us about maybe there's a lot of 3D in there. Even the graphics that you interact with are kind of 3D, and I know some of them are 2D too, and I don't know which ones are 2D and which ones are 3D, right? Because there's a pretty good job of masking those things and blending them together. But what was kind of the experience about creating those types of graphics, whereas you're usually doing that for a web environment, in contrast to doing those graphics and implementing them inside of the Surface framework and that sort of thing?
Well, these two guys over here, it was the first Surface app that I had actually worked on, and so there was a lot of background testing for what graphically was and was not going to work. So for the planets, we originally started out as using transparent PNG sequences of actual planet animations rendering around and whatnot, and found out that after you dropped about 10 or 20 of those on the Surface machine, it ended up being pretty processor intensive. So we switched over to 3D models of planets with basic textures on them that Jason then programmatically would change the color of based on a timing selection of going from red, green, yellow, and blue. And then as far as other elements, we had custom lens flares for each of the suns that actually worked on an optical axis. So as you move the sun around the screen, it would actually cast a lens flare as if it would in the real world when you're filming the sun through a lens or a camera.
So going back to the physics engine that Jason put together, when you ported everything over, you're using WPF now, and there was some Flex stuff that was getting ported over. Was there anything in WPF that you used that you didn't have access to in Flex, or was there, what was that transition like? I mean, I'm sure it wasn't just you take exactly what you have over here and make it over here. So what was kind of that process like?
Well, the biggest thing was was a rendering engine that I had to build to go along with the physics engine. And so in Flex you would use like the bitmap and all that stuff. But for WPF, it was actually slower to use like WPF objects and all this because there's a whole lot of properties and events that go along with each object.
Okay.
So in order to get a bunch of particles on the screen, it would start like bogging down after just a couple hundred. So just a quick little optimization was to switch from using WPF to the GDI Plus library, which is a lower level drawing library. And so just transferring to that made a huge difference in the speed and how many particles we can render at once.
And you were saying it went from 200 to 2,000 or something, right?
Yeah, in Flash, before it started bogging down, I was doing about 400 particles.
Okay.
But with GDI Plus, I didn't even have to go over 2,000 because it just kept going with it without any problems. And so we just capped at 2,000 because we knew there's going to be other stuff on the screen.
Oh, cool.
So.
And then, so you built the physics engine and moved it in, and then somehow there's a transition process between, taking everything from the physics engine side of it, kind of, you mentioned, I think when we talked earlier about wrapping this thing in a WPF object, and then, obviously it transitions over to what Jason was doing inside the application itself. And so, how did that process work, and kind of how did that transition work between you guys?
When I imported his library, all I did was when I wanted to create a particle for his physics engine, I would just call his particle class and create it that way, and then add it to his physics engine, and then his physics would just take in control from there. And based on that, I would use that as my center point for all my other objects like a sun, planets, things like that. And from that, as the particle would move around, it would just tell me where to move my object.
Okay. And then you talked a little bit about multi-threaded applications. In addition to this being your first Surface app, it's the first multi-threaded app that you'd been really involved with too, that heavily. How did that process work as far as being able to optimize things? And at what decision point were you like, okay, we can't just run all this on one thread anymore, I need to start multi-threading this to get the performance that I need?
Well, when we first started, we were able to put a handful of objects on there, and they would perform really well. But once we got more than that, and more things were happening on the screen, it would just really have a hard time catching up with everything that was going on. And at that point, we had to start investigating other ways to do it, and that's where threading came in. And with that, each time I needed to create an object, such as a planet or whatever, of an explosion, I would just create a thread for that and place that in the program. And I couldn't communicate from the presentation layer to that thread, but I could communicate from the thread to the presentation layer. So that made it really easy to render my graphics, images, and things like that, as well as the objects and the 3D aspect of it.
Cool, yeah, and you mentioned the 3D, and I think that's probably something we should talk about too, is that this was a Chroma Depth 3D application, and I know that everything kind of works on layers and colors, but Jim, maybe you want to talk about just kind of how that process works, and how you guys created the graphical elements to kind of work inside of that paradigm.
Yeah, the Chroma Depth 3D process is basically taking colors in the color spectrum and splitting them out into different depths, or what you would perceive as depths, based on which colors they were. So for instance, reds would appear to be 2 to 4 inches floating in front of you off the surface you were looking at. Yellows and greens would look a little bit farther back, and then blues and blacks would actually look like they were sunk into whatever area you were looking at. So, and basically what it is it's the way that the glasses are polarized that allow that color split to basically happen to give that illusion of depth. So based on that, what we did is we took the 3D planets and the suns and everything along those lines and assigned them different colors based on what depth we wanted them at. So if we wanted to be way in the background, of course, they'd be blue. And if we wanted them to look like they were popping off the screen, we'd make them red, which allowed for some interesting interaction in that you could have a planet that is blue circling around in the exact same orbit of a sun that has a planet that is green, and they look like they would collide if you were just looking at the screen, but because they were at different depths, once you had the glasses on, they would actually just go over on top of one another. So
yeah, and I noticed we had some collision detection too, so like they're the same color and they're on the same layer and they would run into each other.
Yeah, so for instance, a planet that was blue could hit another planet that was blue, which would trigger just an image sequence of an explosion and a very loud, absurd sound effect to go along with that. And then we also set it up so that anytime any planet of any color collided with the sun, it would explode, the theory being that the sun is so huge and massive that it would just pull in any planet regardless of how far away it was. So.
Okay.
Same thing with the particles as well too. So when Jason's particle emitter would happen, we sprayed it out at like reds, blues, greens, and yellows. So as it started flowing around the planets and the gravity and everything along those lines, you got this weird kind of depthy dust kind of effect over the background layer of the nebulas that we had in there.
Yeah, and there's a lot of objects on the screen at once too. And I think even going back to the kind of the multi-threaded with the graphics side, there was a lot of stuff going on, and we had to come up with some kind of interesting tricks to be able to minimize the amount of objects on the screen when it kind of started to get overloaded. I don't know who wants to.
Yeah, one of the fun elements we had was a UFO that would come in and actually just shoot a bunch of photons at just random directions, and if they collided with a sun or a planet, then they would explode. And what originally started out to be a fun idea of like, hey, let's just have stuff explode from a UFO, ended up being a performance enhancer in that, like, once you had 10 people mobbing on the table at one time, the performance would start to slow down after a little bit when you had just tons and tons of objects. So we just kind of picked an arbitrary number of how many objects could be on screen at one time, and then once it got above that, we would bring this UFO out that would start clearing out stuff, which allowed the performance to maintain at the rate that it needed to and not bog down the system.
Yeah, and I thought that was a cool feature because it was as adding to kind of the experience being a UFO, and not a lot of people would probably pick up on the fact that was really driven by kind of a mechanism to increase the performance by bringing the amount of objects down on the screen. That's a cool thing to point out, that designing these multi-user experiences are so much different than taking a website and sticking it on a Surface machine, or taking the traditional iPod application and sticking it on a Surface machine. That when you start incorporating more people, there's a lot of other paradigms you have to consider and stuff. And I remember I saw Jason a lot of times over there with your hand and like different contorted ways of touching the table, trying to figure out how that menu system was going to work, and it ended up really, really cool. So I'm really curious, if you just want to start with Jason and kind of work our way down, but what was kind of the thing that stood out for you on the project? Maybe one of the obstacles that you overcame, or what you're most proud of, or kind of what you remember as kind of highlights of this kind of short but really engaging and demanding kind of experience.
I mean, like one of the big obstacles was, I guess, kind of the entire thing was writing a physics engine and then writing a rendering engine, and then even being in a language that I had never written in before was just this huge like undertaking. But then, I mean, I think I spent maybe a week and a half on it, and it came out pretty rock solid.
Yeah. Well, in the last 2 weeks of the thing, you were involved in you were on our FizzPop team too.
Oh yeah.
So the last 2 weeks of development, you were doing kind of double duty a little bit. I mean,
yeah.
Some of the physics stuff was done, but.
Yeah, I mean, a lot of the grunt work for the physics part was done by the time FizzPop came around, but I was still working on Genesis while doing FizzPop at the same time, and that was there was a lot of lost sleep during that.
Not a lot of sleep. So, what about you, Jason? What do you think was the best experience you had, or something that, I mean, obviously you talked about the threading earlier, but maybe including that, or what else was something that you'll take away as one of the best experiences about working on this Surface project?
My biggest experience was along with the threading. Without using that threading, I don't think we would have gotten done what we were able to do. But personally, what I got from it was just the fact that being it demonstrated down at South by Southwest, being able to say, people are demoing this project I had a hand in, it's going as a big hit, and a lot of people are having fun with it.
Yeah, it was like a mob at South by Southwest. For anybody who I think we have another video out there that shows some of that, but it was absolutely ridiculous. Well, thanks you guys for taking the time to kind of talk to us about the project and everything. It sounded like it was a really cool experience, and it's definitely been a huge popular hit for for all the Surface devs out there and public in general. So I guess until we do the next one, thanks.